All right, everybody. Picking this whole biochem thing back up. Today we're going to talk about macromolecules, and really what we're going to talk about today, more so than anything else, is how we make and break macromolecules. Okay, so when I say macromolecules, I mean larger sized molecules. So that would be the four that we're going to talk about specifically in this class: is carbohydrates, lipids, so known as fats, as we would commonly think of them as proteins, and nucleic acid. Now, a lot of us don't know what nucleic acid is. That's fine. Just a little precursor to what we'll talk about later. We got DNA and RNA. Okay, so really what we're going to spend this video is about what we call condensation and dehydration synthesis. Two reactions where condensation reaction and dehydration synthesis, where we make macromolecules, and then hydrolysis, or add water back into that and we break them apart. So let's get into it. So these are organic molecules. They macro kind of means giant or big, and there's six key elements to these. Carbon, let's see, 1, 2, 3 are all of them, every single one. All right, this one we see in, so this was in every single one. This one we see in protein and nucleic acid, and then this one we see in nucleic acids. This one we also see very rarely in nucleic acids, a lot less, but we do see it. So, talk a little bit about what a monomer and what a polymer is. Okay, macromolecules, as we said, are large molecules. Okay, so you need bricks to make a large house. You're going to need little bricks to make a large molecule. So a monomer is one subunit of whatever polymer we're talking about. The polymer, poly, many, all right, are the macromolecules. So the polymers, for what we're talking about, are the fats, are the carbs, right, are the protein, and then last but not least, I put a lot Na. I use Na a lot for nucleic acid. So the polymer is the big, huge thing all put together. Each of them have their monomers or subunits that make them up. Not in this video, but in the next video, we'll talk about each one of these. All right, and you will need to know each monomer for each polymer. Okay, I'm just telling you now. If you don't like that, I'm sorry. I can help you build a bridge to get over it. Okay. All right, so the process by which we put these bad boys together is called polymerization, and we'll talk about two ways we do that. All right, so monomers are connected by a reaction in which two molecules are bonded together, and in that they will lose a water. So condensation is the loss of water. Dehydration is the loss of water. Okay, we call them that because they are losing water. So at the end of these molecules, we have an H and an OH. When they come together and when they snap together, so to speak, right, we'll do a little kind of call it a lab, but it's more like a demo cutout thing. They will be removed, all right, and you will be taking out water and putting them together. Okay, so in this case, we've already put three monomers together. We're adding a fourth. So we're coming here, and we're getting a new covalent bond there, fairly strong bond between those three, and then adding that fourth on. Okay, so we're adding in, or sorry, we are taking out water. That way, that's why we sometimes call it a condensation or dehydration reaction. Okay, so water is removed in a dehydration reaction. On the flip side, we can disassemble them. All right, so we got this long chain of these. We can add water and we can break them up, and it's called hydrolysis. Hydro means water, lyse is to break. So process essentially the reverse. We're going to add water in this time. So we're going to put that H back here, that OH back here. All right. And we end up with our monomers. And it'll add, if we were going to break this all apart, we'd add a water here, add a water here. Okay. You do this in digestion. All right. One of the multitude, billions of reasons why water is important to you is you take in water, it goes to your stomach. It can help aid the digestion because it will help mechanically break these huge macromolecules down, especially if you're thinking like carbohydrates and proteins. They can be hundreds of thousands of monomers long. You got to break that up into manageable pieces, into things that we can actually use in our body. We can't use a big, like, I don't eat bread, and then bread goes down, and your body just takes it like, thanks for the bread, and puts it in there. No, it's got to break it down all the way into something it can actually use in the form of glucose. All right, so that's all we're going to talk about right now. I'm going to leave it right there, and then this next video will be a little bit longer. We're going to jump into all four different types of macromolecules.